Hello, welcome students. Today we are going to start lesson number 15, sound. Now students, can you recall what is sound? Sound is a form of energy which produces sensation of hearing in our ears. Sound needs a medium such as air, water for propagation. Now, how is sound produced? Sound is produced by the vibrations of an object such as a stretched membrane or a string under tension. Now, we'll study about production of sound. We have learned that sound can be generated from a vibrating object. With an example of tuning fork, we will now learn about how a sound is produced due to such vibrations. A photograph of tuning fork is shown in the picture. A tuning fork is made of two prongs and a stem. Keeping the stem steady, if the prongs are struck, they start vibrating. So children, you can see in the figure 15.2a, it shows a stationary tuning fork. Stationary means steady. To show the state of air around the tuning fork, vertical lines are used. Here, the vertical lines are equally spaced. It indicates that the average distance between the air molecules is the same everywhere, and the average air pressure in three regions A, B and C is also the same. If the stem is kept steady and the prongs are struck, the prongs are set into vibrations. It means that they are set into periodic motion in forward and backward direction. We will see step by step the result of such a motion. If during the vibration the prongs of the tuning fork go away from each other as shown in figure 15.2b, the air outside the prongs is compressed and the pressure there increases. Such a state of high pressure is created in region A in the figure. The region in which air is at high pressure and high density is called compression. See, understood what is meant by compression? The region in which air is at high pressure and high density is called compression, which you can see in figure 15.2b, that is the region A. In the next step of vibration, the prongs of the fork come close to each other as shown in figure 15.2c. In this case, the air molecules near the prongs get more space to move away from each other. As a result, the air pressure in this region, that is region A, decreases. Such region in which air is at low pressure and low density is called rarefaction. See, what is meant by rarefaction? The region in which air is at low pressure and low density is called rarefaction. Students, you can see in figure 15.2c. However, the air molecules in this region which were in compressed state earlier, that is in figure 15.2b, region A transfer their energy to the air molecules in the next region, that is region B. So, the air in that region goes to compressed state. See, you can see in the figure 15.2c, region B. Such a periodic motion of the prongs creates compression and rarefaction in the air, and these are propagated away from the prongs. These are nothing but the sound waves. When these waves reach our ear, the eardrum vibrates. Accordingly, specific signals reach the brain and we get a sense of hearing a sound. Now use your brain power. If sound waves are generated in air, what moves away from the source? Is it the air itself or the state of compression and rarefaction created in the air? See what will happen if sound waves are generated in air, the state of compression and rarefaction created in the air moves away from the source. Propagation of sound and medium. Students, we have learnt in the 6th standard that sound travels through some material medium like solid, liquid or gas and reaches us. But what if such medium does not exist between the source of sound and our ear? See, we are not able to hear the sound if there is no medium. For example, in the space, we are not able to hear any sound because there is no medium, that is air, in the space. Sound generation and propagation needs medium like air. A simple experiment can prove this. The experimental arrangement is shown in the picture. In this experiment, a vacuum-tight bell jar is placed on a smooth horizontal surface. The bell jar is connected to a vacuum pump via a tube. We can remove air inside the bell jar using the vacuum pump. As shown in the picture, the bell jar contains an electric bell which is connected to the power supply through the lead of the bell jar. At the start of experiment, the vacuum pump is off and the bell jar contains air. If the key to electric bell is now switched on, the bell start ringing and the ringing can be heard from outside the bell jar. Now, if the vacuum pump is switched on, it starts removing the air from the bell jar. As the quantity of air inside the bell jar decreases, the level of ringing sound heard outside also decreases. If the pump is operated for sufficiently long period, the quantity of air like inside the bell jar will be low. At this point, the level of ringing sound will also be very low. This experiment demonstrates that sound generation and propagation needs a medium. If the air inside the bell jar is totally removed, will we be able to hear the sound of ringing bell? Why? We are not able to hear the sound because there is no air inside the bell jar. Always remember, two astronauts on the moon talking to each other directly will be unable to listen to each other even if they are very close to each other. The moon does not have atmosphere. Since there is no medium which is necessary for generation and propagation of sound between the astronauts, direct sound propagation between them is not possible. Therefore, the astronauts use some technology like the one used in our cell phones to communicate with each other. The waves used in cell phone do not need any medium for propagation.